of June lead code challenge, and we have a problem of invert binary tree. The problem statement is very simple and straightforward. We have a binary tree and it needs to be inverted as an output. The given is a binary tree where 4 is a root and 2 and 7, and these there is a left subtree and there is a right subtree, and in the output we need to flip left subtree with the right subtree, and for each level. So we can have two approach here. Either we can go with the recursive approach or the iterative approach. I will go through the recursive solution, and then we will see what is the time complexity and the space complexity of this problem. This is one of the classical problem of recursion, where we need to go through each node of the binary tree and then we have to flip the left subtree with the right subtree. So let's start with the coding. We will see how the recursion works here. So one of the base cases, if root is null, if root is equal to null, just return null. It just says that if there is an empty binary tree, then the return binary tree is also empty. After that, we will take left subtree is equal to root is equal to, we will call the invert tree root dot left, and we will declare a temp right, which will contain the right subtree for all the levels. And then after that we will just switch root dot left is equal to temp dot right, and root dot right is equal to temp left. And after the end of this, we will just return our root. Okay, let's try to run this. Yeah, it works. I will try to submit it. See the details. Yeah, there were 68 test cases and all of the cases are passed, and my runtime bits are 19% of JavaScript solution. Okay. What is let's think about the time complexity and the space complexity of this solution. Since we are visiting each node at least once, the time complexity for this solution is big O of n, and the space complexity, because of recursion, the space complexity of the solution is big O of h, where h is the height of the binary tree, and because big O h number of functions will be placed in the stack in the worst case scenario, where h is the height of the tree. And yeah, so that's pretty much of it. See you tomorrow for the second day of the June lead code challenge.